Hey guys, my name's Fig. I'm one of the co-founders of Squid, and Squid is a cross-chain swap and programmable money SDK, API, and set of front-end developer tools. And I'm going to be talking about merging Web2 and Web3 development and how we can build apps as easily as possible. So the first question is, why develop in Web3 at all? I think everyone in crypto thinks about this a lot. Web2 is very easy, it's extremely scalable, super cheap, it's mature, we've got tens of millions of developers making modules all the time that make it really easy to make an application and get straight to the logic that you want to build in your application and not worry about any of the infrastructure, any of the payments, all these small details. So what does Web3 add? Web3 adds ownership. Ownership, we think at Squid, is a basic human right. And I put human in brackets there because really ownership is something that an agent has. It could be a human, an individual with a private key. It could be an entity, which are called companies in the old system, DAOs now. It could be an AI that purely lives in the digital realm but has ownership through blockchain technology. And ownership's important because it allows us to transact with each other. If you have X and you want to trade that for Y, then someone else needs to prove that they have Y. And with blockchains, we've started with Bitcoin, just with one chain, super simple. You can check on the chain through this distributed open source technology that someone else owns what they say they have. And then Ethereum came in, we have programmable money. You can have a smart contract that owns things. Maybe you own a certain share of something in a protocol, and you can still prove that through this open permissionless infrastructure. And that's what we're adding on top of Web2, in my opinion. In Web2, we have this experience of ownership, like we have money in a bank, but at the end of the day, the bank is the one that really owns the money. And we see this in these big risk events like black swans, market crashes. And we think this is really important because transacting with people is what makes the world go round, and making that as risk-free and simple as possible is really important. So also, Web3 allows you to innovate at the protocol layer. In Web2, we're given to us, Web2 is quite mature, so the protocols have developed to just be worldwide. We have SMTP for email, for example, HTTPS. But with Web3, you might develop an application on top of a protocol, but then experience this huge innovation in this protocol layer that might make it more cheap, more scalable, and you have to adapt your application to this change. You have to have some strategy of maintaining your code so that you don't have to spend all of your time just keeping up to date with all the protocol changes, and you can keep focused on your logic. And this is a feature, not a bug, the innovating on a protocol. This is why Web3 is so powerful. But Web3 dev is really hard because of this constant change. We need a way of minimizing the effort to maintain code. We need to choose between the best tech and the best users. And this is obvious when you think about the degens chasing yield around the ecosystem, chasing airdrops. You might build your application on one chain, but all the users are on Arbitrum chasing an airdrop on one particular application, and then they move over to this new chain that just launched. How do you build your app in this Web2 fashion so that anyone can come and log in just super easily and not have to think about the underlying chain infrastructure? And then there's the complexity of dealing with the core technology on the protocol that you're developed on. So how gas works, how you index data, how you get information from block explorers. And for example, if you want to get a user to access your app in the Cosmos, but you're built on your app in the Cosmos, but the user is on Arbitrum, how do you encode the data for the transaction on Cosmos in the context of a Solidity contract on Arbitrum? There's so much complexity there, and that's what Squid is trying to solve. So, Squid is like Stripe, but for crypto. We allow you to, anyone, say you're a US, the example in Stripe is you're a US citizen or you're an Australian citizen, EU citizen, you can come with your bank account and pay with whatever money you have in your account. And we do that with crypto. So whatever tokens you have in your account, you can go to an application and be guaranteed that you can pay for the product onboard into it. We're like Google Maps because as all these chains and roll-ups start appearing and the pathways between them get more and more complex, you really need a separate service to find your way, find the best path. And we do DEX aggregation as well. So if you're swapping tokens, you might need to find the right DEX, Uniswap or Curve or whatever, to get the right trade. And Squid is programmable money forever. Forever meaning as the protocols change, you still have your one application interface that you've developed with, and that's not going to break. It's actually just going to keep expanding as more chains brought into existence and maybe new wallet infrastructure comes in. This interface is still going to work, and your total addressable market of users is only going to grow. So Squid takes security as our first focus because cross-chain can be really scary. We're powered and secured by Axelar, which is an amazing technology. They've had 60 or 70 audits and have a whole blockchain just dedicated to verifying messages. Everything is in a single click. Because if we are going to compete with Web2 or build these Web2-like experiences, we need to have single-click flows. Don't want the user waiting 20 seconds or waiting 15 minutes for an interaction. The contract calls across chains is that programmability of money that I talked about. Needs to be able to charge a fee. Instant execution is needed, and dealing with gas is another issue in Web3 that we abstract for our devs. What this looks like is a suite of developer tools. We have front-end widgets, an API, and an SDK that developers can use to integrate their applications. And we've deployed smart contracts on most chains that we're integrated with. This is what the API interface looks like. Super simple. You can just see I have tokens over here, and I want to get tokens over there from chain to chain. And then at the end, you see pre-hook and post-hook. And that's the programmability of money, where the pre-hook allows you to put any application logic you want before the payment or before the transfer of value. And the post-hook is any logic afterwards. And we could have just built a cross-chain swap app with Squid. We could have just sat with get tokens from A to B. But really the mission here is to connect all users and all smart contracts, all agents, no matter where they are, and keep this sort of really efficient, fast market of anyone being able to interact with anyone on the globe. So that's why we've got them there, and I'll show some nice examples of them later. One of the developer tools that we have is wallet abstraction, because when you have multiple chains, there are only a couple of wallets which support a lot of chains, and not everyone has them. So you can see here there's 65 chains. I'm not sure how many. Yeah, 65. And we support 22 wallets already. So you can serve users who have their money in any of these wallets. We have a swap widget that you swap from any chain, and in under 20 seconds and one click, all these nice things. And this is where we get into the programmability. So this is DYDX's interface, and DYDX recently launched a whole new chain just for their application. It's called an app chain. And in order to get users out to that new chain, it was actually really complicated. There's a complex combination of different bridges, different swaps, and sorry, that's to protect my eyes. Every 20 minutes, I look away from my screen. So to get to DYDX, say you're an Arbitrum, you have to first bridge to Ethereum, then bridge to the Cosmos, then swap, then bridge to DYDX. And just saying that sounds confusing. Trying to get someone to do all those steps one after the other, and each one takes potentially 15 minutes, was just not acceptable for DYDX. So they integrated the Squid API, and it's now just one click. And in a lot of cases, it's quite fast. It's less than a minute. And you can deposit from any token on any chain now. So I think we've onboarded hundreds of millions of dollars into DYDX by now. They launched recently. This is an NFT use case for Squid, where think of it like Shopify. Like you go to Shopify and you list a product, and you then go to the checkout page. This is where you'd see Stripe usually, and anyone with their payment of choice can buy the product. With what we've done, that button where it says ETH, you can click that and select any token on any chain. Log in with any of the 22 wallets, select a token that you own, and then just click buy. Yeah, and for Stargaze, this was also, it used to be a meme. There were Medium articles. I think it was actually 30 steps that a user had to go through to get stars on Stargaze, which is a Cosmos chain, and buy the NFT. And now it's just a single click. This is what's happening. Some swaps on a DEX, bridge via Axelar, swap on another DEX, bridge via ABC. Once it arrives on Stargaze, it buys the NFT. And it all just happens magically under the hood. This is our feature called Boost, where you can, it's an intent-like design, which lets you get any of these flows to happen in less than 20 seconds. Really proud of this feature, and it is just necessary, I think, for any widespread adoption of crypto. You can see the architecture of it here. So the way it works is the user essentially describes their intent on the source chain. They say, I want to bridge to Optimism, and then swap these tokens, do whatever. And usually that bridge step would take 20 minutes. And this is where users don't know if they've got their money until the money really lands in their account 20 minutes later. Really scary experience, waiting for your money to arrive. So instead, we have a Boost provider who can be anyone, and they provide, say it's 100 USDC that's going across the bridge. They provide 100 USDC instantly and give it to the user through this. Maybe they swap in a DEX, buy an NFT, do whatever, and the user receives what they want instantly. And 20 minutes later, the money pops out of the bridge, and instead of going to the user a second time, it repays the Boost provider. It's a nice little feature we added for the user experience. And yeah, we handle all these things, the payload generation, the execution, and I think indexing and tracking is actually a big thing, because how to communicate with each blockchain and check whether something's worked or not is also really complex. And we have one API interface, it's called our Status API, which lets you just hand off all of that work to us. The use cases, I've gone through NFTs already, staking into LPs, doing DeFi, works really easily. We're working with some blockchain games, and you can create these wallets where you just hold assets. You don't need to care what chain they're on. And you can pay on any chain that you want to look at. These are some of the real projects that have integrated us. I think we're up to between 300 and 400 at the moment. Some really great names in there. Yeah, any questions? No, looks good. Thanks so much. Follow us on Twitter, look at our docs. Happy to chat.